Hello friends, welcome to Sekho. In this video I am going to talk about instantaneous velocity and instantaneous speed. But before doing that, I am going to remind you about a simple fact that you already know. Let us say this is a line and I want to find its slope. So let us say this is a line and it is PQ. Now if I want to find its slope, I have to know what is the x-axis. Let us say this is x-axis. So what I have to do is I have to just extend this line until it touches x-axis. I will extend this line. So I extended it and let us say it touched the x-axis. Let's say it touched the x-axis in this point. Okay, this point, let us call this point R, and we also draw a perpendicular line from Q. It is perpendicular to X. We call this point S. So if this angle is theta, then the slope of this line PQ is tan theta. Tan theta is the slope, and it can be written like QS by RS. No problem. And we can do it in this way also. We draw a parallel line. This is parallel to x-axis, and this line is perpendicular to x-axis, and let us say this point is T. So this angle is again theta, same theta. This is also same theta because this is parallel and this is common line, so this and this angle will be same. So in that case we can write tan theta is QT by PT. QT by PT. It is perfectly okay. Or we can just take any random point here and we extend it little further, and then we draw a parallel line to x-axis, and we draw another perpendicular line to x-axis. Let us call this point A, this is B, this is C. Then tan theta, this is again same theta, and in this case tan theta is BC by AC. So all these ratios are same, their values are same, and they are just tan theta. That means they are the slope of this line PQ. Okay, so this is what I wanted to say. You may already know this. Now let us go to the exact problem. We want to define instantaneous velocity. So let us say this is position axis in meter, and this is time axis in second, and here let us say this is the position time graph. Let us say this is 2 second, this is 2.5 second, then this is 3 second, this is 3.5 second, this is 4, this is 4.5, then this is, let us say this is 5, then this is 5.5, then this is 6 second. Let us say this is 2 meter, then 4 meter, then 6 meter, then 8 meter, then 10, 12, 14, and so on. So let us say we want to find average velocity about 4 second. So around 4 second, what is the average velocity? This graph is actually curved in the upward direction, that means its velocity is increasing as time is passing. Otherwise it would have been like a straight line. Okay, so the car is moving in on dimensional, this is on dimensional motion. Car is moving along x-axis and its velocity is increasing as it is moving forward. That's why its curvature is like that. So we want to find the velocity, average velocity around 4 seconds. So what we do, we are taking this point P1 and let us say this point P2, and we connect these 2 points directly. Okay, so average velocity is like how far it has moved in that direction in that time, and what is the time it has taken. So how far it has moved is this much. So initially it was around 1 meter and finally it is around 8 meter. Okay, it is around 8 meter and initially it was around 1 meter. So what is the distance if we call this delta x? So delta x is x2 minus x1 is equal to 8 minus 1 meter, that means 7 meter. And what is the time it has taken? If we call this delta t, this much time, delta t, then delta t is equal to 5 minus 3 second, so it is 2 second. So what is the average velocity in this time? It is delta x by delta t, that means 7 by 2 meter per second. Now if we reduce, so this is average velocity from this point to that point, okay, or from 3 second to 5 second, or from 1 meter to 8 meter, its average velocity is 7 by 2 meter per second. But if we want to choose these 2 points from 3.5 to 4.5, we connect these 2 points. Okay, we connect these 2 points. So in this case delta x will be this much and delta t will be this much, isn't it? So in that case we will find delta x by delta t. We have to just see how much it is and then how much delta t is. We do delta x by delta t and we get average velocity. If we take even closer points, okay, it becomes almost a straight line. Okay, and if we keep making delta x smaller and smaller and smaller around 4 second, it just becomes like tangent to this curve, isn't it? It becomes like tangent. Now we are seeing that the slope of this line gives the average velocity. Now when delta x is too small, extremely small, infinitesimally small, the line becomes tangent, and if we find the slope of tangent, we will get velocity exactly at 4 seconds. Exactly at 4 seconds. You have to use your intuition here, imagination power here to understand this, that if we keep decreasing delta x at some point, the delta x becomes so small that you can say that it is just velocity, average velocity, or just velocity, instantaneous velocity at 4 seconds. So this is graphical representation of graphical understanding of what the instantaneous velocity is. So finally, what is instantaneous velocity? Instantaneous velocity is you draw a position time graph, and you take any time, and you just draw draw a tangent to the position time graph in that time. So the slope of that tangent becomes the instantaneous velocity of that time. For example, in this case, when we are considering 4 second, what we have to do, we have to just draw a tangent line around in 4 second, tangent to the position time graph. This is tangent. Now we have to find its slope, okay, and that slope is the instantaneous velocity around 4 second. Slope becomes the instantaneous velocity of that time. So this is graphical representation of instantaneous time. This video is already 11 minutes long, so in the next video I will try to explain numerically what is instantaneous velocity. Okay, so thank you for watching. I'll see you soon in the next video, and if you like this video, subscribe this channel and hit the like button, so that YouTube algorithm thinks that these videos are valuable and they show these videos to more and more people. So thank you for watching. Bye bye.